Well, let's take a look at some examples on how we determine where we have parallel lines by looking at a particular equation. So here, let's have, say we're given y is equal to 5 over 3 x minus 2. Okay. Let's say that we are also given y is equal to x, and let's say we're given y is equal to 5 over 3 x plus 4, and let's say we're given y is equal to x plus 1. Okay, so now given these particular 1, 2, 3, 4 different set of equations, we are to determine by what we've learned from the definitions. And keep in mind, from the definition it says that if we have two non-vertical lines, they are parallel if and only if they have the same slope. So we don't really have to graph these, but we will graph them just so we can take a real good look at it and see how it looks from a picture. But let's take a look at the first one. We have y is equal to 5 over thirds x minus 2. We know what the slope is in this situation because the equation is written in y is equal to mx plus b, and in this format we know that m is the actual slope, which is the change in y over the change in x, which is equal to our rise over run. So with that, we know using this particular equation m is the slope. So in this particular first problem, our slope is 5 over 3. We also know that in this particular problem that b is going to equal our y-intercept. Okay, so b is going to equal to our y-intercept. Also, y is a variable and x is a variable. Okay, these are the things that we know. If we look at these problems, this is what we know, and this is how we can analyze what's going on with this problem, because this is what we know. So let's take a look at it. We just looking at the slope, Something else we may want to something that you may want to do. Those of us that's already fluent, we don't necessarily have to, but in this case we may, where there's, what did it say when the rules say, well, there's no variable or there's no coefficient in front of the variable? You remember what the rules say? The coefficient is always 1. So you may want to go and put a 1 next to these particular variables with no coefficient. So now that makes the number in front of x, the coefficient in front of x, that makes that 1. So it's easy now for us to look at this and say, well, if I'm comparing strictly by the coefficient in front of x, then we could say this particular equation and this particular equation has what? They have the same slope, which is 5 over 3. So no matter how we graph these in a coordinate plane, these two will be parallel. These two. Also, we can see y equals 1x and y equals 1x plus 1 we can also see here, if we were to just looking at the graph, nothing more, just looking directly at the graph, we could see that these two particular equation has the same slope. So if they have the same slope, they are parallel. So we can say, I mean, just simply looking at simply, I mean, not even putting a coordinate plane on paper, we can look at this and say that the first equation, equation number 1 here, is parallel to equation number 3, and equation number 2 is parallel to equation number 4. Now we could take a look at these to see how they graph out, but we want to take a look at those on our TI-84s. We are going to use these to make sure that we can see what these particular graphs look like. But again, these two particular lines, 5, 3, 5 over 3x minus 2, 5 over 3x plus 4 are parallel. We are not at all concerned with the y-intercept. The negative, the minus 2, and the plus 4, we are not concerned with at all. That's actually going to keep the lines from touching. We're just determining here from the slope, from the rise over run, whether the lines are parallel. And with this 4 different problems, we can see from these 4 different problems which 2 lines are parallel. All right, thank you. We'll see you for the next example.